Now on to functions. A function f from a to b is said to be onto if every element of b is mapped by at least one element of a. So better I'll take some picture and I'll explain you instead of going by the definition. See this? Let us assume that there is a function f from a to b. This is set a and this is set b, and let us say we have 4 elements here and we have 3 elements here, right? Now if every element in b is associated with at least one element here, then we can say that it is onto function. For example, see this is onto function because every element, if you see in b, is associated to at least one element. Now see this, a function f from a to b is said to be onto if each element of b is mapped by at least one element of a, that is range of f equal to b. In this case, what is the range of this function f? The range of this function f is the entire set b, because all the elements of b are actually participating in the relation, right? So I'll just give you one more example. Let's say we have 1 2 3 4 and 1 2 3 4. Now see this. Now if this element, if it didn't map to this one, if it goes and maps here, then it is not onto, because we have left out one element without mapping to the element in a. So every element in b has to be mapped to an element in a. If it doesn't happen, then we can say that it is not onto function, right? Let us say the mapping is like this, then we can say that it is onto function. Now can you say that, so what should be the condition for a function to be onto? Can you just imagine this one? Let us say a is here, b, a is having 3 elements and b is having 1 2 3 4 elements. Just see what happens now. Even though you try to give one element to every element in b, since there are less number of elements in a, it is not possible. Therefore it is not onto function and it can never be onto function. The reason is this simple. See, the number of elements in a are less than number of elements in b, then there is no way every element in b is going to get an element in a. So the condition for a function to be onto is like this: number of elements in b should be less than or equal to number of elements in a. So you have, it is not the sufficient condition, it is a necessary condition, which means even if this is satisfied, it does not mean that a function will be onto. But if it doesn't satisfy, then the function is definitely not onto. Are you getting it? If you see that the number of elements in b are larger than the number of elements in a, then you can directly say that it is not onto. But if you see that the number of elements in b is less than number of elements in a, you cannot directly declare that it is onto. You have to see the mapping and then answer it. Are you getting this? See, for example, if I have some elements like this, a, b, 1 2 3 1 2. Here the number of elements in a in b is less than or equal to number of elements in a, but you cannot directly declare that this is onto function. You have to see the mapping and then say it. For example, if all the elements are mapped to the first one, right, even though the number of elements in b are less than number of elements in a, it is not onto, which means that is just a necessary condition and not the sufficient condition. What is the sufficient condition? Every element in b should be associated to one element in a. If that has to happen, first that condition should be satisfied and next the other condition. Got it? So what can you say about one-to-one and onto functions here? Is this one-to-one function? It is not one-to-one function because many elements are related to one element, right? So when two elements have the same image, then it is not 1-1, which means this is the example of a function which is onto but not one-to-one, right? And what about this one? This is the example of a function which is one-to-one and onto. Got it? Now what about this function? This is example of a function which is not one-to-one because many elements are having the same image, and not onto as well. Got it? Now just tell me what happens when you have equal number of elements in A to B. A and B if they have equal number of elements, 1 2 3 here, 1 2 3 here, right? And which means I'm talking about this number of elements in A is equal to number of elements in B, right? If this is the case, and if it is already known that there is a function f which is 1 to 1, which means every element here can have at most one image there. If it is already known as 1 to 1, then what can you say it? So if the number of elements are same and if the function is known to be 1 1, then it is also onto, then it will become onto. Why? What could be the reason? If it is definitely going to be 1 1, which means every element here will be mapped to a distinct element here, then how many distinct elements we have? Exactly as many as the number of elements in A. Therefore every element in B has to be mapped, then only we are going to get a 1 1 function, right? Now let us say the same one, the number of elements in A is equal to number of elements in B. Okay, this is the case. And now if it is known that it is a onto function, onto function means every element here is going to get one element here, right? Then what can you say about it? So if it is this condition, number of elements in A equal number of elements in B, and it is known that the function is onto, then it is definitely going to be 1 1. What could be the reason? Since the function is going to be onto, every element here is going to be mapped to at least one element here. Now we know that if that has to happen, we should exactly have at least these many number of elements in here, and we have them, right? And every element here cannot have more than one element there. That is why it is going to be 1 1. Got it? And one important question: if these two are equal, then how many onto functions are possible? Of course it is n factorial, right? Why? Because onto functions also can be made in the same way. You take each element here, then how many choices will it have to be mapped here? N. You take each next element will have n minus 1, next element will have n minus 2, because every element has to get one element, isn't it? So you cannot make two elements go to the same element, then it will not become a function. So n factorial. If cardinality of both the sets are equal, then the number of onto functions is going to be n factorial, and the number of 1 1 functions is also going to be n factorial, right? Okay, in fact, if the cardinality of both the elements are same, and if you try to make either it as onto or 1 1, then the other property will be satisfied. But it is not always the case if the number of elements are not equal. Okay, so the cardinality or the number of onto functions possible from a set A to set B when the number of elements are different, which means when the number of elements are not same. When number of elements are different is going to be bit different question. Okay, what I'll do is I'll give you the formula for that, and then we shall see the questions on it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.